Florida isn't flat. This site climbs over 100 feet from low to high. Before any earth gets moved on a construction site, civil engineers run a cut and fill analysis. Cut is where the existing ground sits higher than the proposed design grade. Material has to be excavated and hauled away. Fill is the opposite. Soil has to be brought in and compacted. We're focused on the grading footprint, the portion of the site that's actually being reshaped. Across that footprint, the design reworks about 50 vertical feet of terrain. Two surfaces are being compared cell by cell, the existing ground from a LiDAR survey and the proposed design from the civil engineer. Subtract one from the other and you have a depth grid for every 2-foot cell. We start at the deepest cut, the magenta band at the highest natural point, and work down. As shallower bands light up around it, the full cut zone emerges, tracing the ridge that runs across the site. The deepest stays visible the entire time, so you can see how much material has to come out of each location. Engineers use this map to stage the work, typically removing material from the top down in lifts, sized to the equipment on the job. And the shape itself tells you something about the natural terrain. A long, narrow cut like this traces a linear ridge, the kind you find along Central Florida's sand and limestone uplands. Now the fill begins. Fill is the inverse of cut. These are areas where the existing terrain sits below the proposed grade and has to be raised up. Valleys, drainage swales, low pockets, anywhere the design calls for a buildable platform above the natural ground. The cyan bands are shallow fills. As they accumulate, you can see the proposed plan emerge. Equipment pads, building footprints, road embankments, retention areas. Engineers set those elevations based on drainage, flood criteria, and how the site connects to the infrastructure around it. The deepest fills, in electric blue and violet, are engineered structural fills, placed in 6 to 12-inch lifts, each compacted to a target density, verified by an in-field test before the next lift goes on. Unlike cut material, fill has to meet a written specification. Clay-rich soil that works in an embankment may not pass under a building pad. Skipping that step is what causes the slab cracks, and settling owners complain about years after the ribbon cutting. Notice the fill zone is much larger than the cut zone. This site isn't balanced. It's being raised overall, and the extra material has to come from off-site. He numbers about 161,000 cubic yards of cut, 333,000 of fill, a 2-to-1 ratio. The site isn't balanced. Roughly 172,000 yards of imported fill have to come in before construction can start.